What's going on, everybody? I hope this is working. Sorry I'm late. I had to spend all morning just screwing around with the audio. Because we're doing something with audio today, and I wanted to be able to hear my desktop and record my desktop at the same time. What's going on, everybody? I hope this is working. Oops. Sorry I'm late. I had to spend all morning just screwing around with the audio. Oh, there we go. It was playing through Facebook. That's going to sound real weird. Okay. So let's get to it now that things are working, I think. Just waiting for, okay. My wife confirms audio is good. Thanks, son. Let's jump into it. Today we're doing something a little more fun than Bash, I think. We are making a game with the pico-8, which I just installed yesterday. There's the startup noise. So the pico-8 is pretty cool. It's a little game emulator that you could buy on Linux, Mac, and Windows, and even the Raspberry Pi has a late. It's meant to emulate something like the Atari, but it's not actually like a real system. I think it's kind of just a fantasy emulator. So if I type help, I can see some commands. Let's look at the demos. So if I do install demos, it dumps some games to this demos directory. Let's go inside of there. So why don't we just load Collide? And then I'm going to go run. And then so the thing about the cool thing about the pico-8 is that any time when you have a game loaded, you can jump into the code and like hack things up. And you could even like make your own sprites, like this bunny or the ball here. I can like, you know, make it blue. And then if I go run, it's blue. So there's some sweet demos, but we're gonna make our own. So let's see if I can clear the screen. All right, I want to clear the game I've loaded. I haven't used this in a while. Shut down. Why don't we just reboot? That's always a safe bet. All right, rebooting. Let's get started with our own game. The pico-8 is written in Lua, so we're going to be writing a type of Lua, and it gives you these functions right off the bat. One of them is draw, and the draw function is run every time the screen needs to refresh, so like a bunch of times, you know. So that'll be almost like a constant ticking game clock. And then why don't I look up, I'm going to open up another Firefox tab because this is going to be a lot of Googling. We're going to get there. So pico-8 draw circle. Oh, I'm also going to set my 25-minute timer. All right, the circ function, X, Y, draw a large red circle in the middle. I like that. So circ 64, 64, 32, 8. So if we run that, call global draw. I wonder if I defined my function wrong. Oh, I bet it's func. Nope. Pico-8 draw function. Oh, it's function. Okay. And it's an end. Man, I wasn't even close. All right. So it is function end. Okay. There we go. All right, so it drew the red circle of the screen. Silly part, though, is it didn't clear the screen. So I think we need to also clear the screen out before we draw anything. So CLS. There we go. Beautiful. Okay. So the pico-8 screen is a square, and I think it's 128 by 128 pixels. But let's do some little experiments just to mess around with figuring out like where the geometry is. So I think that circle, let's make it a little bit smaller. So let's see. This function takes an x, a y. That means 32 must be the radius. So let's just make it 10. That should do a smaller circle. Okay, cool. So what happens if we draw the circle at 0, 0? Top corner. Okay, so top corner is 0, 0. That makes sense. And so that's the, now, why do we make it 0, 32? Okay, so the y, so now we're advancing down. So that must mean, so the 128 coordinate must be at the very bottom then. Let's try making it 128. Beautiful, okay. And then as expected, if I go 128, that should be our bottom right corner. Cool. And then 128, 0 should be top right. Okay, cool. So if we want to draw it smack dab in the middle, I think it's just going to be 64, 64. Because that's 128 divided by 2. Perfect. Okay. So the game that I was thinking about making is I wanted to make a game where you control a guy who's flying down toward the ground on a parachute, and then you have to go back and forth and like avoid things. I thought that could be kind of fun because we could draw like clouds, like birds for him to run into, keep score, things like that. But let's draw a sprite. So we're going to exit this out first. So I'm going to draw his parachute just in kind of like a hoop on the top. What color should we make the parachute? I want something nice and happy like orange. And then I kind of want a guy who's like holding parachute strings. Maybe we'll make it go down just this big. And then for the guy, we'll give him like we'll give him a nice wide pale face. And then how about some brown hair? And maybe he's wearing a red shirt. And he's got stubby little blue legs. Perfect. And then how about he's also got his arms sticking out, and then he's holding on some strings, so we'll make those white. There. You sort of see what I see? So that's his head, holding on to some strings. All right, cool. So now instead of the circle, we want to draw the sprite to the screen. Let's see if we can just be dangerous and guess what the arguments are. I think it's SPR for sprite. Whoops. No character found, SP. What did I do here? Alright. We're going to... Why don't we do this? Save parachute P8. And I'm going to reboot. There we go. Okay. Load parachute. I accidentally hit an Emacs command, which I would not recommend in this pico-8 editor because everything gets all screwed up. Okay, so SPR. There it goes again. What the heck? What did I do? Pico-8. No care found. Numlock? No, not Lenovo. Sample cartridge, file system. Commands. Reset pico-8 keyboard. Key config. I've never seen this screen before. This is interesting. So let's save. Where if it's here. Oh, was I on katakana mode? Control K. That's what I did. Okay, we're back. Katakana, what is that? Pico-8. Yeah. Katakana. Interesting. Well, I'm glad we found it. Alright, we are drawing the sprite to the screen. SPR, I think it's going to be the sprite number. And then 64, 64. That didn't work. Pico-8 sprite draw. SPR sprite number. Oh, maybe it starts at 0. I think N might be 0. There's our little guy. All right, so we got our parachute. And I think I was just inspired to shave these off, make it look like more of a hoop, you know? All right, so the next thing I think I want to do is I want to attach some key bindings to him. So when I hit like the left key, I want him to move to the left. And when I hit the right key, I want him to move to the right. Let's try that out. So that's going to happen in a different function called update. Update sort of does what draw does, where it's kind of in the internal game clock. It's going to run the functions in here like each time. So you can, but the reason why it's different is because drawing images to the screen has sort of different expectations than update. Like update are things that need to happen. Like a player is, you know, in the game universe physically located here, and then draw is just like sort of the rendering. So the interesting thing about the Pico is it's optimized to drop frames if it has to catch up, which is why, like, you know, if it's animating something across the screen slowly and for some reason you like run out of frames, it'll kind of fudge the difference for you and make it look smooth. But update is for stuff that we really can't fudge. You know, like a player is either at this coordinate or he's not, that kind of thing. He's either alive or he's dead. So that's why things that are like logical, like, you know, like where is my player going, update. So Pico-8 keyboard button. All right, so the button function tests if a button is being pressed at this moment. The button. So we're going to hand it the button number, I, and then the player number, P. That's interesting. Okay. I think we're going to stick to just one player for now. But the 0 button is the left. So why don't we do if button 1, left, statement. How did those look? If then else. Okay. That's pretty easy. It's kind of like bash, just with fewer semicolons. So if then so we're going to move our guy to the left. Okay, interesting. So at this point, we're going to need to update a value that's just in draw for now. So why don't we create like an x and a y outside of all this? So original x is going to be 64. Original y is going to be 64. X and y. Well, that's the sprite number, so we're going to leave that. X, y. All right, cool. So if the left button is pressed, we are going to, we want to go to the left. So that would be decrementing the x value. So x is equal to x minus 1. Else button 1, I believe button 1 would be the right. We're going to increment the x equals x plus 1. And that makes sense to me. Y is changing for now. Or y is staying the same. Let's run that, see what we get. Unexpected symbol near then. Wonder if I goop something up. Oh, should it be else if? Else if, yeah. Else if. There we go. All right, so I go left. Nothing's happening yet. Let's see what we did. X and Y. Pico-8. Print to screen. We could use a little place to print debug messages just to see if we're falling into the right code path that we expect. So print string xy. All right. Let's make a little log function. Well, that's probably overkill for now. There, I like that. So we'll go print current log message, and then we'll print it up at the top left corner, which would be 0, 0. Test log. Logs go here. Perfect. Alright, so if we fall into here, we're going to set log moving left, and if we fall into here, we're going to set log equal to moving right. Interesting, it's not even hitting there. Okay, so if we're not even falling into here, why don't we do this? No, we don't need to do that. Okay, so if button 0, that means button 0 is never... Oh, I'm not comparing it to anything. I'm just doing if button 0. I probably need to compare it to like if... Well, no, because button should just return a Boolean. Let's see what they got in the code samples. If button 0. So if, yeah, looks right to me. Lua if button. Let's see if there are any code examples out there. Oh, that's interesting. If button equals 0. Okay, so falling into update. I wonder, are we even getting here? Here, why don't we do this? Okay, so we're at least getting that far. So the documentation for button. Test if a button is being pressed at this moment. Yeah, this is kind of what we want to do. If button 0. Wonder if the comments are making them in. Let's get rid of those. Yep, nothing yet. So it's never falling in error. That means button 0 is always returning false. What does button P do? Test if a button has just been pressed. Oh, I see. Okay, we probably don't want that, but good to know. All right. Why don't we do this? If button button 0 Interesting. Let's just try copying what do they have in the docs. Let's make sure I'm not losing my mind. So it's an update. Yeah, that's not working either. Function update. They have draw after update. I wonder if that does anything. Put this here. Don't think that should make any difference. Oh, I don't have a C in here. So far, a little disappointing. I didn't think I would get stuck on this part. Pico-8 button not returning. We could try loading some other examples. Here, why don't we do this? Dir C demos, dir. Why don't we try loading collide? We've got an init function. Let's see, where is update? Yeah, draw for each actor, move actor. That's clever. Okay, yeah, here we go. If button 0. They have parentheses around this case here. I wonder if you need parentheses. Let's try that. Let's load parachute. Oh, you have to start over anyway. Maybe that's good. All right, x 64, y equals 64. We're going to draw. Got our parachute guy still there. Let's see if we can get this working before I take a break. We're going to draw a sprite number 0 at x and y. And then for update, we're going to go if parentheses button 0 x, decrementing x by 1, if button 1, incrementing x by 1, and then we also want our log message. Logs go here. Print log 0, 0. Unfinished string. Interesting. Oh, forgot the quote. Unexpected near end. I'm going to try putting the thens back. Still not working. Dang it. That looks right to me. I'm stumped. All right, let's take a coffee break. Maybe we'll get some clarity. All right, I'm back. I was looking at some other example code, but I think I have some clarity. There's an easier way to test this. Why don't we just do this? Let's delete this for now. And log equals button 0. Oh, interesting. If I hit down, it's true. Button 1. Why does it think all buttons are down? So 4 is up. Were we lied to? What's going on here? Pico-8 button. Interesting. For some reason, the key maps are different than what I'm seeing in the docs. Did I accidentally change them? Let's see. I was messing around in that key config command. Press delete for default. Whoops. Escape to cancel. Oh, everything got screwed up. Alright, that was my fault. Save config. Press escape to continue. Okay. So now everything should be working. So we're going to go button 0. Okay. Dang it, I messed up the key map. Alright, we're going to cruise now. Just watch this. So we're going to go if button 0, that means we're going left. We're going to decrement x by 1. Else if button 1, then increment x by 1. End. And we're also going to add our log lines back. Left. Right. Look at that. So let's do the same for up and down. So else if button, wonder what button 2 is. Button 2 is up. So that means we're leaving x the same and we are going to decrement y because we're heading to the top of the screen. Y equals minus equal 1. Else if button 3, and it would stand within reason to say button 3 is down. Y plus equals 1. And then there's end. All right. So we have free motion now with our little parachute guy. How fun is that? We could even go oh, interesting. So I tried to move diagonally by hitting up and to the right at the same time. It did not work though. And I think I know why. It's because we have it all within this one if statement. So it might be a good idea to check the x coordinates and the y coordinates separately. So why don't we do this? We're going to go end if. Okay, so this is update y. This is update x. And now we can move diagonal. Look at that. Cool. All right. So now we could start to add some other game elements. I was picturing like a bright blue sky that our little dude is floating down. We probably want to do that in the draw function. Pico-8 fill. We could do rect fill, draws in a rectangle shape, where you give it a x0, y0, so upper left corner, lower right corner, and then the color. That seems fine to me. So we want to clear the screen. The order actually matters here. So we want to clear the screen, and then we want to draw like a baby blue background with rect fill. And then that's 0, 0, 128. 128, because that should fill the whole screen. And then we're going to want the color code. Pico-8 color codes. Ooh. That looks nice. It's index 12. We want to draw 12. Beautiful. Looks great, except now his legs are missing. Why don't we give him some black pants? We'll give him some blue jeans. Nice and rustic. All right. Okay. I think one thing that we could do to help complete the illusion that he's like in a parachute falling is if we like made him sway. You know how like if you're swinging with a parachute. I think with a little bit of animation we can get him to sort of like rock back and forth. So let's see if we can figure that out. All right. I first want to, let's see, stamp from clipboard. Select. I'm going to copy paste this guy. Let's see, pan. How do I copy paste? Let's see. Pico-8, copy paste, Sprite. Clipboard. Import, export. Whoops. Interesting. Pan, fill, shape. These are like different sheets. Control C. Oh, there we go. It's just Control C. And then stamp it. Boom. All right, so let's make one where he's swaying to the left. So I'm going to go back into draw here. Let's erase this guy. So trying to use my imagination, I could see the parachute kind of contorting a bit, like, you know, flinging this way. And maybe his red shirt's like over here now. And maybe we'll draw like just one like stubby to kind of make it look like it's bent behind him. We gotta have his chestnut hair. Oh, let's see, did I make him too big? Yeah, I did. Okay. So his legs are shorter than that. It's going to be a problem. There we go. Now he's smaller. Here's his red shirt. I guess we don't really have much choice of the legs. But we can still make it look like his arm is reaching out. And it's on a white string. There. We'll draw the white string here. Okay. So it sways to the left. And now I wonder if we can, well, we might be able just to invert that. I know there's some pico-8 functions for just drawing something and then like flipping it, like mirroring it over the y-axis. So maybe we can just get away with, you know, we should try to optimize. We should try to draw as few sprites as possible. All right, so since we drew the swaying to the left, why don't we try to attach that to the left moment, the left key command. So I'm going to make a new variable. Zero, none, one, left. We'll go with that. And okay, so if you press the left, it's going to change the sway to 1. And then right is going to change sway to 2. I'm going to move this up here. So 1 equals none, 1 equals left, 2 equals right. That's kind of what I'm going for. And then if neither of these are being pressed, we're going to just reset sway back to 0. Perfect. So now at this point we have two different sprites because we have 0 and 1, and we have to know based on sway which sprite to draw. So why don't we do this? We're going to leave the clear screen rectangle fill and print at the very top, and then we're going to go if sway equals 0, then we're going to draw, okay, so if sway is equal to 0, that means we're not swaying, and we just do what we were doing before, x and y. Else if sway is equal to 1, then sprite, so if it's equal to 1, we're swaying to the left, and we should just draw sprite number 2. Well, actually, I think I had that right. It's 0 and 1. We have sprite 0 and 1. And lastly, if sway is equal to 2. So now we need to draw sprite 1 except invert it. Sprite 1, x, y. And the sprite function should have some other parameters that we can pass in to let you do that. Yeah, there we go. So we have n, x, y, width of the range. Default is 1. So we're going to have to, I think we're going to have to pass in the defaults here, 1 and 1. And then flip x. So we are going to inverted left to right. We do want that. Okay, true. And actually, I just saw a way that we can shorten this up. So since this is getting a Boolean, well, let's just see if that works first before we tinker with it. Run. Look at that. It's exactly what I was picturing. Woo! It's kind of fun. All right, I just saw a way that we can clean this up. Since this is a Boolean, we can go ahead and just pass this comparison right into there. Sway is equal to 2. And that means we can check this out. We can get rid of that. And we can also get rid of that. And just make this else. Nope. Expected symbol near then. Unexpected. Else. Oh, I think we don't need the then here. Perfect. I love it. Adorbs. All right, we got swaying down. Let's draw some clouds. We should probably make a sprite for a cloud, huh? So a cloud, it's going to probably just look like a little puff of smoke. Since we want these to be just in the background, I don't think we want to draw a lot of attention to them. I think that looks like a cloud. That looks fine to me. What do you think of that? So let's try to plant a cloud. That's going to be sprite number 2. And we'll just throw it in the corner, see how it looks. Here's our cloud. Okay, so obviously we want to create a whole bunch of different clouds on the screen, and we don't want to have to just have them appear in the same place each time. That would be a little tedious. It would be cool if they could appear in like random spots, and then eventually I'm going to want them to like move up to create the illusion that we're falling. And I think since we're going to have a lot of stuff on the screen, we should start to think about the pattern that we want to use. I want to get everything a little bit more encapsulated, like sort of break things up into like entities, and then I don't have to know so much about like, you know, I want to get rid of these global variables like sway and x. So let's do some refactoring. I'm going to try to make an entity for our player. And then, you know, instead of just doing all the calculations with setting globals, we can just interrogate the object, and then update can just be a little more generic. So let's do this. I'm going to go init. So as my init function, my goal is to make this the only global, just objects. OBJS, we'll go. We'll call them. And then, let's see, Lua, add to list. Inserting and removing. Okay. So I'm going to kind of write just the init function before I go ahead and write the player. So we want table insert objects, and then I'm going to go make player. So that's kind of just the pseudocode that I want. And now we need to write what the make player function actually does. So function make player. Okay, so there is a way to do like object-oriented stuff in Lua. It's the syntax is a little goofy, so it may take some Googling, but I think we could figure it out. But in general, I think we want to create an object and then at the very end of this return it. So I'm going to go local O and then return O. Okay. So that's what I want to do on a init. I think I'm going to want to just have like this one global objects list, and then I just want to be like for everything that we need to draw to the screen, I just want to be able to throw it in this list. And then for update, instead of all this stuff, which let's be a little gutsy, why don't we just comment it all out or delete it all? I'm confident that we could recreate that if we had to. Glad the mouse wheel works. So Lua for each in list. Okay, I think we're going to want something that sort of looks like that. So for, I probably didn't need to copy it. We can just make our own. So for object in, I think for Lua everything is just like a hash. Like I don't think there's any just straight list, so it'll just give us an index anyway. So I'm going to do for I for index and object in OBJS. Do, and then this is what, end? Yeah, end, okay. And I'm going to want to call object update. And similarly for this draw, let's just make a new draw function. I want to do something really similar for draw. So function draw, that's going to be the same thing. For I, object in objects, do object draw. Cool. Oh, interesting. I think I need I pairs. I forgot about that. In I pairs. I got into trouble now. I changed a lot more than I probably should have, but let's just see if we can dig our way out. I pairs, objects do. Okay, well, if our player is still drawing to the screen, then we know we're in good shape. We still want that, because that's the background, and we still want clear screen. There we go. Let's get rid of these globals. And then, so we want to make our own update function, and we want to make a draw function. So, O draw. I think we have to do function O draw. And this is where we actually draw our sprite. So we are sprite number 0, and then we want to do an O x equals 64, OY equals 64. think it's self x, self y. We're going to have a lot of code to dig through. Let's just see if that works. Did not work. Unexpected symbol near O dot. Let's see what happened. Lua set attribute on object. Looks right to me. What happened? So that's blue. I wonder if something happened there. Attempt to index global table, a nil value. Pico-8, add to list. Oh, okay. Interesting. So the table, that must be a Lua thing and not a pico-8 thing. Adds element to the end of a sequence of a table. Okay. So instead of that, it's going to be add. So we're going to add to objects the result of make player. And then, why do we do this? Instead of creating it there, I'm going to create it at the top. Obj. There we go. All right, a little further. Attempt to call method update. Oh, interesting. Oh, okay, cool. So it must have been able to find draw. So now we just need one for update. For now, I'm just going to make an empty one. Perfect. All right. And he doesn't, so it looks like he's in the middle of the screen, but the very top. And that must be because we don't have a Y. And I don't know why that's working all of a sudden, but it is. Perfect. All right, cool. So now I like this pattern more because we sort of have things like tucked in a little object. Oh, thanks for watching, Caleb. I just saw you. So why don't we try to repurpose, or why don't we try to move the left, right, up, and down inside of O update, and that should be a little tidier now that we're like sort of inside of our own little player object. So I'm gonna go, why don't we do this? Local left, if button 0, then that's gonna be self.x minus equal 1. If button 1, then self y, or x plus equal 1. If no, I think I like it written out how we had it before. I was trying to be tidy about it. All right. So if button 0, we're going to go self x minus equal 1. Else if self button 1, self x plus equals 1. I think we want that. Whoops. Unexpected symbol near then. Do I need that? Then expected near self. Okay, we do need that. Else if button 1 What happened here? If button 0, then self x pico 8 if then. Conditionals. Conditional statements. Oh, so you do need a then after else ifs. So else if button 1 then. That's why it was man. All right, so left and right is restored. That's good news. We're going to make the same thing for if button 2, then self y is decremented by 1, else if button 3, then self y incremented by 1. Beautiful. So now we gotta put the swaying back in. So we should be able to write something a little more compact and isolated since we're inside of this object. So I wonder if we can write a function just to return the sprite, because that's something that's, or we can also just put it in draw. All right, how about this? We're going to start it off with O sway equals false, because by default he's not swaying. And then if you're moving left, we're going to say self sway. Not really a Boolean though. All right, we'll use our number system from before. One equals left, 2 equals right. But by default, sway is equal to 0. For moving left, sway is equal to 1. Self sway is equal to 2 if we're moving to the right. All right, cool. And then when do we do this? We're going to go local Sprite. If we are swaying, I like moving into a function. So Sprite. Let's call it Sprite no. Sprite number. If self sway is equal to 0, then we're going to return 0. Else, return 1. So we can just replace this with self Sprite no. And I'm going to break that up into a few different lines because it's getting a little big. Self x, y. Okay, so we have our two defaults that we need need there. And then this is the parameter we pass in to determine whether or not we invert it over the x-axis. So in this case, we just want to pass in self sway is equal to 2. Because if it's equal to 2, that means we're swaying to the right, and we need to invert the second sprite. We've got some errors. Self sway is equal to 0. Local self. Oh, it doesn't know what self is. Interesting. Can I not reference other functions this way? Self sway. Yeah, I don't think I'm going to screw around with self. I think I'm just going to use O instead. As far as I could tell, it does the same thing. Like I'm just referencing that local object. Yeah, I can't tell you how Lua interprets self. I think every programming language kind of does it differently anyway. It's weird because that stuff is working down there. All right. Oh man, what a mess. Okay. Yep, not using self. It's also extra letters. I don't want to type that each time. There we go. See? Alright, we're swaying. Cool. That's fun. Alright, 12:52. I think we have time to add some clouds. So I'm going to go, let's try to add one cloud. Function make cloud. Same kind of pattern. We're going to go local O is an object. We're going to return O. And this should be easier because for the draw function, we're just drawing a cloud. Sprite. We are sprite number 2. And then OX, OY. Why don't we just start off putting it at the top left corner again? XY. And then we also need an update. All right, we're going to add one cloud. So add objects, OBJS, make cloud. Perfect. All right. So this is the fun part. Now we have a really nice little entry point where we set the coordinates here. We can like randomize them a bit. Let's see how to get a random number in Lua. That way, when we make a cloud, it appears at like a random point in the screen. So Lua random integer between. pico-8. Random integer. RND. Generates a random number between 0 and the given maximum. Perfect. Let's do this. RND 0, and our maximum is 128. Because that's where the screen ends. Expected, what did we do here? Line 65. Oh. All right, cool. So each time I reload the game, there's a cloud in a different spot. Sometimes it's off the screen. Oh, it's not. No, we're good. I was just hitting refresh too fast. All right, let's add a bunch of clouds. So that's going to be in a init. Lua repeats n times. P to function act n times. Where was that page I was looking at? Which was like pico-8 Lua. That's what I wanted. Okay, let's look at loops. While and repeat loops. So for C015, okay, that looks easy enough. So for N, and then equals 0. Why don't we start with 20 clouds? Do. Int. Okay. Look at that. We got 20 clouds now, and they're all random. Another issue, though, I saw a cloud can spawn on top of a player. We probably don't want that. So let's move. Our player should be added on top. So let's move this guy to after we do all the clouds. There we go. So now there's no possibility of... Yeah, see, you even saw one there. There's no possibility of clouds shadowing on top of them. All right, and then the last thing we can probably fit into this section, I would like to make the clouds like fall up to make it look like we're falling. And we have our own update function for that. So on each tick, we want the Y to be decremented because we're just a falling cloud. So 0.y is equal to 1. Look at that. Isn't that fun? There's another issue, though, is that we're spawned with a finite number of clouds, and then they all just disappear. So now it's clear to me that we need to like continually add clouds, like whenever they disappear. So how about this? If O.y is less than 0, meaning it fell off the screen already, then destroy is equal to true. I wonder if it's easy to do that in Lua. Oh, perfect. Yeah. Looks like, okay, so what I'm thinking is when the cloud should know, it should like flag itself for destruction if it falls off the screen. And then somewhere in update, we can just destroy it. So within updates, and so we're going to update, and then why don't we iterate again for I? Well, we could do it within the same loop. I wonder if that's going to cause problems if we're deleting the same data structure we're iterating over. We'll find out, I guess. If object destroy, then delete del from the table, obj, and then obj. Yeah, because we don't want to just keep spawning infinite clouds. We'll eventually run out of memory. But that being said, we also want a place to keep adding clouds. So that's on init. And then within update, I think we can add a cloud on each tick. If not, we can always do a random number between 1 and 5. Let's see if that's too many clouds. We'll just add one each time. So that's add objects, make cloud. Unclose function, line 48. Oh. Okay, that doesn't look right. That looks like somebody's shooting at him. Well, I like the progress we made. My baby's crying, so that's probably a good stopping point as any. Let's save our work. Save. Anyway, thanks for stopping by, everybody. That was a lot of fun. We will pick up on this next week, see if we can get the class.